Let's talk about garbage collection. So in the last video, we sort of demonstrated how garbage collection would look like in a browser when you are writing JavaScript. So in this video, I just mostly wanted to explain what are the sort of requirements of it, what problem it aims to solve, and like how it approaches, how JavaScript approaches to solve the problem, right? So since we discussed that garbage collection is sort of a way of managing memory that sort of languages utilize. So it has its own kind of algorithms which different languages handle it kind of differently. We'll sort of going deeper into how JavaScript does it, right? So why is garbage collection required? So what the fundamental concept that you can sort of sit on for this is you have limited amount of memory, right? So you cannot just go on utilizing or allocating whatever you want to the limited amount of memory you have, right? So that's where garbage collection that's where memory management comes in for any language. So when you're designing a language, you should be sort of consider about those factors, because memory and CPU, those are like fundamentals of or the core of whatever things like the perform, how your language is going to perform, right? So you have to sort of have some mechanisms to optimize those aspects. So some languages give that responsibility to the developers, like you have full control, but we won't do anything for you. We have given you the tools, you do everything or you manage it however you want. While some tools decide to handle it on your own just to make it easy for the developer so that they can sort of focus on the need in hand, right? Rather than going into the details of those things when they don't have to. So JavaScript sort of took a second approach where they sort of introduce garbage collection so that devs can normally focus on building applications and websites and stuff, and they don't have to worry about the low level sort of things like memory management and all. So that's how garbage collection come into place. So what garbage collection does is in context of JavaScript, it will periodically clear out the garbage, as in clear out the unused memory or things that you initialized once but you don't require now. It will clear those out so that it can be utilized by something else, right? So that's the basic point of garbage collection memory management. So that's the problem that it aims to solve. So the first thing that comes to mind is, how will you know that something is not being used anymore or anything as such, right? How will you know that it's actually garbage and you don't end up like clearing out memory that is already being used, which will maybe crash your application or something? But yeah, so that's not a very healthy thing to do, right? So the initial approach that sort of came into garbage collection is reference counting. So how will you know that some object is being used? So you sort of start at a point and you count the references that point holds. Like this object has this particular variable has a reference to this object or this function or this thing, right? So in which places it is being used, and are those functions relevant? So if the reference counting if the reference drops to 0, then it is sort of marked as garbage and it's cleared out, right? So that's how reference counting works. If any of your variable, or if you think at a very low level, if anything in the memory has no reference attached to it, it's just standing there on its own without being used anywhere else or no reference as such, then reference counting comes in place and it says that okay, you have 0 references, you'll be garbage collected so that your space can be used by someone else. That's what. But one problem that comes here is what we call circular references. So what happens here? Let's say you have object A which is referring to object B is referring to object A. That's not a very ideal scenario to have, right? So it will never, the reference count will never be 0 in this, because object A is saying, oh, I'm being used by object B. Object B is saying, oh, I'm being used by object A, and so on, right? So that's like a never ending cycle of it, right? So it will always be 1 in this case and not 0 for both the cases. And like it's sort of a deadlock like scenario if you have like heard of it, or if you have sort of heard of the limitations of multi-threading. This is sort of a, not exactly, but they also deadlock also have a similar pattern itself, right? So that's what. So none of the reference counts will drop to 0 even if you aren't using them anywhere, until you manually sort of clear out one reference or both the references. It will be there in memory, and that's sort of like a memory leak because it's wasted space. You are not using them, they are still occupying the memory, and that's because of a drawback or a problem because of the memory management approach that we are taking, right? So here the focus was reference, like the core of the problem solving element was reference. If something has reference to something else, then it's being used, otherwise it's not being used. That was the core analogy behind developing the whole thing, which sort of doesn't work here as we see. The next thing that people sort of came up with is they sort of took the primary philosophy of this algorithm to reachability. So every program you write will have some root elements or root, like whatever to call, like you can have global variable, you can have things in the call stack and so on. Those are like the root of it, and which are being used in many places, which sort of has more items which are being used in many places, and it's sort of from like a tree like structure from top to bottom, and you have multiple trees as such, right? So that's when the concept of reachability comes in. So what the new algorithm says is, if your element is not reachable, if I traverse through the tree from start to end, then it will be garbage collected, right? So you can sort of assume it like if you are into video games and stuff, you can sort of assume it like maybe an FPS game which has, let's say, a stealth FPS game, let's say. So let's say you are a sniper, you have 2-3 people with you, and you are sort of trying to infiltrate a base camp or something, and what are the first things that you target? Those targets which are not being seen by someone else. So you can sort of have a line of sight kind of a thing. Let's say there's a building, there is one person on top of it, he's seeing 2 people below the building, they are seeing 2 people below the building. So those you can sort of think of as references, and maybe there is some person standing beside the building who no one is seeing, so no one has a reference to that. So you first mark the target, and then you sort of mark all the similar targets, and then you, in the game of course, and then you eliminate them, right? So that's how it works. That's the similar thing that happens here as well, and it's called mark and sweep algorithm, right? So what happens in mark and sweep is, you have this root because, like I mentioned, it has to start somewhere. So you start at the root, and you have multiple such tree-like structures, and then you sort of start at the root and you traverse till the end, and if there is anything that is unmarked, you sort of like clear that out, right? So you can sort of, if you want to visualize it, you can sort of imagine it's like periodically JavaScript releases pulses that sort of starts here, and when it moves towards the end, let's say these are connected, and this will light up, this will light up, this will light up, this will light up, and everything that is connected will light up. So after the whole pulse ends, anything that is not being lit up will be cleared out. Then after some time it will again pass a pulse. Anything that is not lit up will be cleared. After some time it will again pass a pulse. Anything that is not lit up will be cleared, and so on. It keeps on running. So that's sort of a memory management thing that that's how garbage collection takes place in JavaScript, like the mark and sweep algorithm. So if you say here also, like the same problem with circular references might be there, but the thing that you need to understand is, this is, let's say, a circular reference. The thing that you need to understand is, this is not the core of this algorithm is not reference, it's reachability. So if this item is not reachable from any of the root elements, it will be cleared, even if they have like interlinked references and so on. And if this itself is a root element, then maybe it will wait and like until it is cleared and so on, right? So that's what. So that, like, the basic thing that you need to understand is, the core principle of mark and sweep is not reachability. The core principle of mark and sweep is, the core principle of mark and sweep is not references, it's reachability. For the previous one, it was references. So that's the difference, right? So yeah, I think that's how JavaScript sort of handles memory or manages memory internally. And yeah, I think that should be it for the video for now. We'll discuss some more topics in the next video. And if you like the video, please share it with your friends and drop any comments if you have any suggestions. Thank you. Bye.